Let's try to solve this problem over here. The volume of mercury in a thermometer bulb at a temperature of 10 degrees Celsius is 0.11 cm cube. So right now when the temperature is 0.11 cm cube, I have my thermometer here. Then they say that the volume of mercury that is inside this thermometer bulb over here is 0.11 cm cube. So let's label the volume over here to be 0.11 cm cube. Okay, this is the volume of the mercury, not the volume of this tube over here. Okay, the cross-sectional area of the capillary tube is 1.0 millimeter square. So means by if we have this, this is the capillary tube, by the way. This very thin tube over here is a capillary tube. If you cut it horizontally to see its cross-sectional area, you can find the cross-sectional area here to be 1.0 millimeter square. So let's draw it. So if you cut and see this area over here, this area here will be 1.00 millimeter square. Okay, given that the coefficient of volume expansion for mercury is 1.8 times 10 to the power negative 4 per degree Celsius, means by if you check for this mercury what is its gamma, you can find that the gamma is equals to 1.8 times 10 to the power negative 4 per degree Celsius. Okay, determine the increase in height of the mercury in the capillary tube, means by this mercury here will experience an increase in height in this tube over here when the temperature of the mercury rises to 27 degrees Celsius. Okay, so what happened is this mercury inside this thermometer bulb here, when it experiences a heating up process, this mercury here will experience expansion. Okay, the volume of the mercury will expand, and because the volume of the mercury expand, it will rise in this capillary tube over here, and they are interested to know what is the increase in height. How much is the increase in height from the initial level over here to the final level over here? What is its change in height? Okay, so we are clear with the situation. What can we say? For these two temperature, the gamma will be the same. Okay, the gamma we usually just treat as being constant throughout the change of temperature. The volume of course will change, but this 0.11 cm cube here is the initial volume. Okay, we are going to assume that the cross-sectional area of this capillary tube to be remain constant. If the expansion will cause the thermometer capillary tube to expand as well, that will make it a bit complicated. But for now, we are going to assume that this cross-sectional area remain the same. So let me label it on the new diagram as well, that the cross-sectional area will also be 1.00 millimeter square, sorry. Now we need to perform unit conversions for the area and the volume that we have here, because as you can see, the cross-sectional area is given in millimeter square, whereas the volume is given in centimeter cube. So let's make sure everything is in SI unit for now. So the original volume or the old volume is 0.11 cm cube. Okay, if you convert it, what you need to do is you need to eliminate the cm cube. So you put it on the other side of the fraction, which is below. Then you replace it with meter cube instead. You know that 1 meter is equivalent to 100 cm, so you can cube both sides of the fraction. Then that allows you to obtain an answer which is 0.11 times 10 to the power of negative 6 meter cube. Okay, next you have your cross-sectional area. Your cross-sectional area is 1.0 millimeter cube. So 1.0 millimeter cube, you would like to eliminate this millimeter cube and instead replace it with meter square, sorry. All these things in square. Okay, so 1 meter is equivalent to 1000 millimeter. So you need to square it on both sides of the fraction. Then from there, you are able to get the area to be 1.0 times 10 to another negative 6 as well, times 10 to the power negative 6 meter square. Okay, so that is your original volume and your cross-sectional area being converted to SI unit. Okay, so now you can perform a calculation, but before you perform a calculation, let's try to understand everything clearly. What you want to find here is the change in height, okay, of the mercury in the capillary tube. You know this change in height happens due to the change in volume of this mercury because the mercury expands. So if you think about it in a three-dimensional way, what happened here that caused a change of height is actually the change of volume of the mercury by this much. Okay, this is the change of volume of mercury. And we learned from the concept video that the change in volume is equivalent to the original volume V0 multiplied by gamma multiplied by the change in temperature. Okay, so we know that the original volume here, which is what we found here, is 0.11 times 10 to the power negative 6, no problem with that. Our gamma, our coefficient of volume expansion, it's 1.8 times 10 to the power negative 4. Then the change in temperature, we know that we take final minus initial, so that's 27 minus 10. Okay, so that's the right hand side. But for the left hand side here, what you're able to find is actually the change in volume. But we know that this change in volume is actually just taking the cross-sectional area multiplied by the change in height. So change in volume is actually the cross-sectional area multiplied by the change in height. So you can replace this change of volume here with the cross-sectional area A multiplied by the change in height. Okay, so I believe you can perform a calculation. On the right hand side, you get 3.366 times 10 to the power of negative 10. This is the change in volume, but we are going to equate it with the cross-sectional area, which is 1.0 times 10 to the power negative 6 multiplied by the change of height. So if you bring the 1.0 times 10 to the power negative 6 to the right hand side, you'll find your change in height to be equals to 3.37 times 10 to the power of negative 4 meter. So it's a very minor increase in height, but this is what you can observe if your temperature rise from 10 degrees Celsius to 27 degrees Celsius.